Welcome to Arithmetic Sequences. So what's special about these sequences? They go up by constant steps. So you might be adding 2 every time, or minusing 7 every time, or adding a fraction every time. These are also called linear sequences because if you plot them, the term number against the term, it will form a straight line. The definition, therefore, is an arithmetic sequence is produced by adding each term in a sequence by a constant value, and this is known as the common difference to obtain the next term. Now, what I'd like you to do is use a method of your choice and find the nth term of these sequences. So pause the video and have a go at doing that. All right, I'm going to go through this. So the standard method for dealing with nth term is to realize what the common difference is, in this case plus 2. So we know it's going to be 2n, and then think about, there's two ways to do it. Either think, what do I need to add to, if when I put substitute in 1, I'll get 2. What do I need to add to that to get the actual first term, in this case 0? Or look at the 0th term when n is 0, and in this case it's 0 as well. So that's the answer. It's just a 2 times table. Here we're adding 3 every time, so it's going to be 3n, but I'm going to need to add 1 to get my 4, or if I go backwards, or minus 3 to get 1. This one going into the negative, so it's going to be minus 4. So it's going to be like the minus 4 times table. But I don't want minus 4 as my first term, I want 3, so I'm going to have to add 7. Or add 4 on this way to get 7. Here, getting them back into algebra, so we're adding 5 every time. It's going to be like 5n, but I don't want 5 as my starting one, I want x. So I'm going to have to minus 5 and then to get back to 0 and then add x. So that could be my answer. I might rearrange it. If I was to do it the other way around, I would have to minus 5 and I'd get x minus 5, which is again the same thing. So yeah, hopefully you're okay with that. Last one. So this one, my first term was x, my common difference was 5. Now I've got a first term of a and a common difference of d. How are we going to deal with this? Well, same method, okay, but now it's in the d times table, so it's going to be dn. But I don't want d as my first one, so I'm going to need to minus d, and then get to 0, and then I'm going to need to add n, and that is my nth term, which I can rearrange to a plus n minus 1d if I'm being fancy. No, actually, not being fancy. This is how we want it. You can kind of see when you look at it that actually that's what's happening. I've got a, and then I've got a plus 1d, but that's my second term. I've got a plus 2d, but that's my third term. So my nth term is going to be a plus n minus 1d. And let's just bring this symbol back in. This means nth term. So the point of that basically was to say that this is the general form of an arithmetic sequence. I'm going to uncover this. The formula for the nth term of an arithmetic sequence is this thing here, where a is the first term and d is the common difference. These are generally used to refer to common differences in first terms. And this is where it came from. You've hopefully managed to get it yourself. You might not have put it in the factorized form, I acknowledge that, but be aware of it. And actually, from now on, rather than figuring all this out, you can simply substitute, because we found the general formula, we can just substitute in A and D if we know them to get the sequences. So you're more than welcome to pause this video and try each of these questions and then replay when you want me to go through them. I'm going to go through these as using the formula now. So question A, right, A, the first term is equal to 6. D, what's it going up in? It's going up in 14s. So I can straight away write down that the nth term is equal to A up here, which is 6, plus n minus 1 times 14. Okay, I don't need to bother with all that other stuff. I just simply put it into a formula if I know what it is. I'm trying to remember if this is on the formula book, but in any case, it's worth just knowing. So I could leave it like that, but it's always good to simplify. It's going to be 6 plus 14n minus 14, and we're going to get 14n minus 8. And that's it. And I could have got that the other way, but you might say it would have been quicker the other way, but just be aware of this formula. That's what this question's about. If I'm doing part B, it's going to be very similar. A is equal to 101. D, this time, it's going down. How many is it going down by? It's going down by 7, minus 7. So UN is going to be A, which is 101, plus n minus 1 times minus 7, which is 101 minus 7n. If I multiply that out, plus 7, careful with the double negative, which is going to be minus 7n plus 108. You might write as 108 minus 7n. Fair enough. Okay, sorted. Next one. The nth term of an arithmetic sequence is un equals 55 minus 2n. So we're given the nth term. I'm not going to go through a and b, like substituting in to find the first 5 terms in the 99th term. We're going to jump straight to this one. This is the one I want to focus on. Find the first term in the sequence that's negative. Well, the really slow way of doing this would be to substitute in lots of values of n until you get there. The slightly quicker way, which actually probably the best way, would be to just realize that, this is going to be an even number, so it's going to be 56, that's going to be it. And when am I going to get 56? It's going to be when n is 23. So you know what? It's going to be when n is 23 and u23 is going to be minus 1. The slightly slower way, but maybe the most careful way, would be to solve when un is less than 0. So that's going to mean 55 minus 2n is less than 0. I don't know how you solve your inequalities. Do you minus the 55 and then divide by minus 2, switching the sign? Or do you add the 2n? Whichever. Just make sure that you've got a method that works. So then I can divide by 2. I can swap the n round. I'm going to do that in one spell swoop. I've just realized I've made a mistake earlier on, which you may have spotted. Why did I say it was 23? It should have been 28. Sorry. See, this is why the more careful way is actually better. Okay, so n is 28, which you can see. So n has got to be greater than 27.5, but because n is positive, sorry, not positive, a whole number, n is going to be 28. And now I can substitute in 55 minus 2 times 28, and I'm going to get minus 1. So this is the quick way, which I messed up. Sorry about that. This is a slower way. I get a decimal. I need to convert it into a whole number. In both cases, we do get n equals 28 and get minus 1. Okay, next one. A sequence is generated by the formula un equals an plus b, where a and b are constants to be found. Given that u3 is 5 and u8 is 20, find the values of the constants a and b. I put this example in mainly to say that, you know what, even though this was the general formula, you might be given an arithmetic sequence that doesn't quite follow that, because in this case, what's going to be the first term? The first term is actually going to be a plus b when n is 1. That's absolutely fine. We just have to deal with these kind of sequences. We could manipulate it into the form that we're interested in, but there's no real need, because all that we're interested in is finding what a and b are. So let's use the information we're given. We know when n is 3 that un is 5, so I can just substitute in n is 3, and that's going to give me that 5 is equal to 3a plus b. Just substituted in n equals 3 and un equals 5. I can do the same with the other one. 20 is going to be 8a plus b. And now I can do a little bit, I can just solve these simultaneous equations. I'll go a bit careful. I'm going to rewrite the top one beneath, then I'm just going to cross it out. And now, why have I done that? Because now I'm going to subtract these, and I'm going to keep everything positive, because I could have done it the other way around, but I'd get minus 15 equals minus 5a. There's just no need, is there? So now we get 15 equals 5a, a is equal to 3. Thank you very much. We're nearly there. Let's substitute it back into this one because it's the simplest one. So 5 is going to equal 3 times 3 plus b. 5 equals 9 plus b. b is equal to minus 4. Hooray. All right, we're going to do 2 more. Okay, so, you know, these are the sorts of questions you can get on arithmetic sequences. And they're getting slightly trickier. I hope you will be challenged by my last one. If you try that one yourself first, I'm quite proud of that one. In the following, I mean, I didn't make all of these up. I took some from a book, but I did make this one up. Okay, so in the following arithmetic progression, the first 3 terms and the last term are given. Find the number of terms. So just turn the problem on its head. Here, I need to work out what n is, but that's okay. The first term is minus 3. What's it going up or down by? Well, up is the definition of the common difference. It would be negative if it was going down. So we're going up by 1.5. I could write 1.5, but I'm just going to rock it and go with 1.5. And now what? I don't know what. I want to find the number of terms. I'm going to call this capital N. I would advise that this little n, I would say, you know, this is changing. It's capital N, which is the number of terms. That's what I'm interested in. So I can write down that U capital N is equal to A plus bracket capital N minus 1 times D. And now I can substitute my values in. So actually, my last term is 12. So 12 is equal to minus 3 plus capital N minus 1 times 1.5. And we've got an equation which we can solve. 15 equals n minus 1 times 1.5. Divide by 1.5. N minus 1 is 10. So n is equal to 11. Now again, you could have done this question by just like counting on 1.5s until you got to 12 and realized that it was 11, but you know, this kind of process is still needed, because what if I made it, you know, some ridiculous number you wouldn't want to count on then? If I added 1,500 and made it 1512, okay, you'd need a method like this in that situation. All right, last one. What a question, I like it. So the first 3 terms of an arithmetic sequence are 1, k squared, and 20 minus k. Calculate both values of k, and hence the 3 terms in each possible sequence. So we just need to really think about what's going on here. We've got that a is 1. We've got a common difference. Okay, so the common difference is going to be the second term minus the first term. Important to realize that. D is equal to second term minus first term. But it's also equal to the third term minus the second term, and so on. And you can use that information to help you out. So D is going to be k squared minus 1. But it's also going to be 20 minus k squared. And we can set them equal to one another to create an equation. In fact, we can just cross out the d now. Not really interested in that. I'm interested in finding the value of k. So I've got a quadratic to solve. I'm going to rearrange it to 2k squared plus k minus 21 equals 0. We're back to first year A level, solving a quadratic where the coefficient is not equal to 1. Different methods for doing this. I just like let's just go for it and try some numbers method. So I'm going to put in a 2k, I'm going to put in a k, and then I'm going to think what could go here to give me minus 21. Well, if I put, well, it's only really going to be, it could be 1 and 21. That seems unlikely given how small k is. Or it's going to be 3 and 7. Now, if I put a 7 here, I'm going to get a 14. That's also very large. So it kind of makes sense to try a 3 and a 7 there. That's going to give me 6k when I multiply the 2k and the 3. It's going to give me 7k when I multiply the 7 and the k. I want a plus k. I want a negative overall, so I'm going to need to make the minus 6k, which means putting a negative there and a plus there. Solve this. It's going to be k is minus 7 over 2, which is minus 3.5, or 3. Those are my two answers. Very hard to do this question without forming and solving a quadratic. So now we just need to work out the sequences. When k equals 3, we're going to get 1, 9, 17. And we can see it works because I'm adding 8 every time. That would have been the common difference if we substituted back in. D would be 8. A would be 1, of course. When k is equal to minus 3.5, we're going to get 1. Then we're going to get, you know, I did this question earlier and I wrote it down. I think I did it on a calculator. So if I square minus 3.5, I get 12.25. And then afterwards, I'm going to get 20 minus k. I'm going to get 23.5 because I would add on another 11.25. Okay, that is the answer. I made a bit of a mess of that. In that case, D would be 11.25. So there we have it. We found both sequences. We found the values of k. Make sure you can do this sort of question. I'd like you to practice some more now.